Welcome to AI for Good, the leading action-oriented global and inclusive United Nations platform on AI. Organized by ITU in partnership with 40 UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end, as we will hold a 30-minute networking session in the neural network. Here you can meet, ask questions to our distinguished speakers, connect, and chat with the AI for Good community. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna. Hello, everyone. Good morning, good afternoon, good evening from me as well. I'm Guilherme Martinez Roura from the International Telecommunication Union, and I would like to welcome you all for joining today's AI for Good webinar on autonomous robots transforming the future of construction, organized by the ITU. This session is part of the AI for Good programming track, where we discuss the role of AI-powered robots in achieving the Sustainable Development Goals. We have a distinguished set of panelists today, but as always, we are counting on you, the participants, to help create a very interactive session. Without further ado, I would like to introduce our moderator today. Her name is Agnieszka, and she's the Global Research Manager at Arcadis. Agnieszka, welcome, and the show is all yours.
Thank you, Guillaume. Welcome, everyone. Welcome to this webinar. It's my pleasure to be actually hosting it today. As Guillaume said, I'm a Global Research Manager at Arcadis. And today we will be exploring how autonomous robots can actually influence the future of construction and also the future of built environment. I'm joined by 4 experts today. You're going to hear from them very soon. 2 of them are representing academia. It's Dr. Thomas Bock and Dr. Carol Manassa. And their presentation is actually going to be followed by 2 representatives of industry, Dr. Bharat Sankaran and Mr. Earl Ahmed. Just a bit of logistics. We have 4 presentations. Each speaker is going to speak for 10 minutes. And after each presentation, I'm just going to ask a very short question. But of course, we would like to encourage you, our audiences, to ask questions as well. So please, whenever a question pops to your head, just put it in the chat, and we are going to ask these questions during the panel session that we will have after the presentations. But then there's another thing that we would like you to ask to do. Basically, we are interested in your opinion, in your thoughts on what are the biggest challenges that construction is facing, and how can robotics actually help address these challenges. So if you could share your thoughts, your opinions in chat as well, that would be immensely useful to us, because then we can basically take your suggestions, take your answers offline, and get also an idea of, okay, what our audiences think about the topic. At the end of the session, there is also going to be an opportunity to network. This is something that, that we will basically guide you towards as we reach the end of the session. And that is actually it from the housekeeping. And let's just move on now to the first presentation. Let's kick off with Dr. Thomas Bock, who is the Chair of Building Realization and Robotics at Technical University of Munich. He has over 40 years of experience in robotics, with more than 50 realized projects in different areas. And he's going to give us a bit of overview of the history of robotics in construction and where are we actually today. So Thomas, the floor is yours.
Thank you very much for inviting me. Here's Thomas Bock speaking. Can you hear me? Yeah. Okay. So as had already been mentioned by the introduction, construction is one of the major industries of the world, deciding the quality of our life. And generally speaking, in the European Union, for example, every second euro is invested in some kind of built environment, that's infrastructure, roads, buildings, facilities, and so on. And recently we have lots of problems considering the high real estate prices, the exorbitant cost of rent, and in major cities all over the world. So we really have to push for a transformation of the construction industry. And here, of course, robotics is the answer to the solution. And let me get into it. First, it started in after the Second World War, in the 60s and 70s. First, the destroyed cities have to be rebuilt. There was first the automation, rationalization, and robotics in prefabrication in order to achieve basic shelters for the people to live in. And later in the 70s, this industrialization prefabrication became more and more customized. And here, especially robotics played a crucial role in order to produce prefabricated one-of-a-kind buildings. For example, here, one of the first systems I did myself was a Masonry Robot, because in Germany, people like to live in brick buildings. But building a brick building by hand takes a long time and has a high labor cost share. So here we produced a prefabrication robot for masonry walls. And here you see how the robot is placing the brick and spreading the mortar. This was exactly now 32 years ago. Another type is the horizontal production type. Here we place the bricks on a huge table, and these bricks were custom made for the brick walls. They could be handled easily by a robot, and also we placed all the services, the pipes already for the kitchen, for the restroom, the windows, and so on. And also the reinforcement could be placed already in the space between the bricks, and then after prefabrication of the bricks could be transported, the whole brick wall could be transported to the construction site. Another big factor is, of course, in construction is the concrete industry. And here we have prefabrication plants. You might recall the traditional precast concrete factories, the one long line, 100 meters and so long, for example. They produce all kinds of components, girders, columns, panels. And here we produced one multifunctional robotic unit with 2 overhead gantry robots that can produce floor panels, wall panels, and roof panels at the same unit. So you don't need this huge, long production line in precast concrete factories. And here the robot is placing the formwork first, and then places the reinforcement. And then later, after the concrete is poured in and the windows are set, even the heating system can all be set. Everything is there already, the plaster and the wallpaper can be placed. And then in the factory can be highly finished and then brought to the construction site. This is an example also from Scandinavia. And as I mentioned before, affordable housing is a big topic now. People can't afford their own apartment or buildings, and so here also about 30 years ago we developed a 888 house, and it had about 100 square meters on 2 floors, and it was prefabricated in 8 days. It could be assembled in 8 hours on site. It was a little bit designed like the Dutch Casco buildings, and it had no cellar, but it was affordable. It costed just like an upper middle class car those days in Germany. So the idea was to double the ownership ratio from 43% to up more than 95%. So we wanted to produce about 500,000 houses per year starting in 1990. And so also possible is the more and more technology advanced, the increased customization. So not producing any more boring panels, but also three-dimensionally curved panels, prefabricated. And here we use the CNC milling machine to carve out the negative form from a styrofoam block and then cast in the concrete and place the reinforcement. So each panel was individually shaped and could be assembled to this curved building. So you can combine individualistic design and prefabrication at the same time. And nowadays, you know, all this 3D printing. Here we worked also with an machinery maker, which is producing parts for aircraft as well. And the first software also we used in the 1990s was also from an aircraft company in France, and we applied it to the construction industry. So by this method, we could also increase the customizability of the mass prefabrication. It's called mass customization. So we combine both the best of both worlds: unique individual design and low-cost mass production. The interesting factor is also that we transfer technology from other industries, like before I mentioned the aircraft industry. Also, Toyota production is very interesting. Toyota production system was not only applied to cars, but also to houses. Toyota also started a housing business, Toyota Homes, and they applied the production technologies for their successful car industry also to the housing sector. And also other companies like Sekisui chemical companies went into housing, and actually the housing companies became bigger than the chemical mother companies, which are a success story, and also increased the ownership ratio and affordability. And here the houses could be assembled even within 4 to 6 hours and 150 square meters on 2 floors. Already kitchen is in there, bathroom is in there. So very high degree of prefabrication and immediate availability. That's also a big factor which we need. And then, of course, the next step is the construction site, because most things on the construction site can go wrong. So here we need to now bring in the technology which we know from the factories also to the construction site. But this is a little bit more difficult because things are moving around and the conditions are not as kind of clearly defined as in the factory. Here show you some examples of the first robots that had been developed in the 1980s. So for concrete leveling, for welding, for setting panels, for exterior wall assembly and maintenance, and ceiling assembly, and so on. Many you can read in the Cambridge books about construction robotics. And here one of the first one in the late 70s was the MTV, the multi-purpose traveling vehicle. It has one traveling unit, and it can be attached to different working units for cleaning, for grinding and leveling the concrete, for example. So it becomes a modular robotic system. Also, overhead works is very bad for the health of the workers. Just remember, dirty, dangerous, and difficult works. Therefore, young people don't want to join the construction industry. We have a problem attracting skilled labor to the construction industry because of the bad working conditions and environments. But because of robotics, we can increase and improve the working conditions for all the workers and make it again attractive for young people to work in this industry. And here, this robot is taking away all the difficult overhead work of the workers, installing, for example, suspended ceilings or air ventilation ducts, and so on. Also for the facade is a very dangerous job, and lots of accidents happens. The platforms, the gondolas fall down, and so on. So here we have a robot for painting and maintaining a facade of the Shinjuku Center building in Tokyo. Also in Munich, we developed a whole family of interior robotics, finishing the whole interior of a building, not only suspended ceiling, but also can assemble interior walls, can place the raised floor, can place floor tiles, wall tiles, and so on. So all the interior finishing could be done by robots, also exchanging the working unit, this time on top of the traveling unit. Before it has been next to it, and here we decided to do it on top. So there are many solutions to develop robots because especially sometimes the interior finishing takes up more time and than the primary structure, for example. And also, it's a good chance to increase the share of female workers on the construction site because of robotics. You need skills of programming and controlling robots. Here, this young Japanese lady has a 2-year additional training for controlling and programming construction robots on site. Next one is also the humanoid workload sharing. So here, this humanoid robot is being tested for collaborating with a human worker for installing interior walls. And then, of course, the most advanced would be the cooperative interior works of 2 robots. One robot, for example, holding the suspended ceiling, and the other one is nailing the suspended ceiling in the interior. So it's a pretty good technology. They are lightweight, and they can cooperate 2 robots together. And recently we did, my assistant, Dr. Iturralde, he did a cable-driven parallel robot. Here you see the pictures from the construction site near Madrid. And he could install a facade. And this was a really difficult task because you have to synchronize all the 8 cables. And he did a great job. He built the whole unit inside the yellow cage, where you first measure and detect the holes that have been drilled to fix the facade. And then the suspenders and the attachments of the facade had been placed, and then the facade can be attached. So this is a very, very interesting task, and can be also applied to other industry, like also maintenance of ships, for example, and so on, because it can move in 3 dimensions. But it's a very difficult project to handle because you always have to synchronize the 8 cables. And this project is being continued right now in our laboratory by Dr. Iturralde. And this was my vision of 1984 when I went to Japan. This was the first construction site, which happened in 1992 and 93 in Nagoya, the first integrated automated construction site. I've been involved in the development as well. Here you see the start, the left side, and then running up like it's a little bit like a vertical shipyard, and about 20 yellow trolley robots working simultaneously, assembling column, beams, and floor panels. And here you see the assembly of a column. This was a part also of my research. I called it robot-oriented design. And so it's easy for the robot to assemble all the components, the columns, the beams, the floor panels, and the facade. So we need a different set of design in order to be successful. We need a totally different approach. For example, here, the detailing of the column joint. And then for the panels, the same thing. So they can be assembled automatically. And for the piping system, piping is very difficult to assemble, you can imagine. So here we used some kind of idea from the shipyards, and then we could assemble the whole bundle together. And this is one of the last sites I was involved in before the virus hit us, and in Osaka. And so the next step is, in order for achieving sustainability, because construction produces most of the waste by volume in the world, so we should reuse and recycle all the materials. And here, for example, we deconstruct the whole high-rise building. We cut the ground floor and lower the building. And while it's being cut and lowered on the ground floor, on the top floors, the interior is being disassembled and cut and placed into 40 containers. So when the floor from the tops reach the ground, they can be drawn out, and then you already have everything sorted in different materials for the wiring, for the carverts, for the cardboard units. And so you can reuse and recycle 93% of the whole building. So it's not just using a wrecking ball or implosion, and then later you try to get rid of the stuff, which is causing a big ecological problem. But here you can really use the materials because they are clean and sorted and separated in a proper way. So 93% of the whole building can be used again. This is, you see it, how the buildings slowly, the twin buildings, the twin high-rise building disappear quietly, no dust like an implosion, no wrecking wall, is pretty nice and clean and quiet. And the next, for the civil works, of course, I mentioned before, infrastructure is a big thing. We need more for public transportation and so on, for tunneling, also for gas storage, for example, here for LNG tanks. These robots are building it. It's a very repetitive job, so they can drill the holes, set the anchor bolts, and pour in the concrete for these tanks. Or, for example, tunneling. It doesn't feel very good to work in a tunnel. It's a little bit like in a submarine, so it's better. Like here, it has been done all automatically already in the 1990s, so about 25 years ago, the Kawasaki Kisarazu tunnel project. Here's the autonomous vehicle bringing in the segments. And then at the end, the manipulator assembled the segments of the tunnel. Or road construction. Road construction is predestined for robotization. It's repetitive. And this one was a project at my previous workplace, University of Karlsruhe. And it was a European project with a company called Vögele in Mannheim. And the next thing is, of course, we have robotic construction machinery fleets. Like here, one person can supervise several excavators or also machines for rescue. And here, for example, after disasters, landslides, after heavy rain, earthquakes or volcano eruptions, it's better to send in autonomous robots or teleoperate construction machines because it still can be dangerous after heavy rains or for rescuing the people or even after volcano eruption. Here you see different applications after volcano eruption and earthquakes. I've been there myself. It's really steep hills. It doesn't look so steep on the picture, but some of these machines, there was no operator on the machine. They were remotely in a control center controlling these robots, and they were tied down. Otherwise, they would tumble down the hill. So it could be only done by this a robotic construction machine or teleoperated construction machine. Here you see a humanoid robot controlling an excavator. This is also for dangerous areas. So you take out the human and replace it by a humanoid. And maybe in the future, we will go into space. Like let's have some space construction for mining on the moon or on the Mars. This could be the next frontier. And we have to think about in the total ecosystem. You can imagine the construction robotics is still like in the age of the horse carriage. The first cars, they looked like a horse carriage without horses. And there were no roads, so the horses were more efficient in the beginning. But once we got the road network, we got the fuel stations, or later we might have hydrogen refilling stations or battery exchange stations. Then, of course, the car industry took off and nobody's using horses anymore. And the same thing has to happen in construction. We need a new set of standards, of building codes, and of the whole ecosystem to bring this revolution of construction robotics forward, in order to also ensure the wealth of the nation in the future, because the rent we pay and what we invest in our housing or in the built environment is the biggest investment we do in our life. Okay, if you want to check more, we have about 300 systems described in our 5-book Cambridge years. You can check it later. We are working on a 6th book now. So anyhow, I'm ready for any questions, and you can send email later as well. So thank you very much, and looking forward to our discussion. Goodbye.
Thank you very much, Thomas. I must say I find it really fascinating. I had no idea that the history of robotics in construction was so long. I think that, you know, we all still sort of have an idea that, oh, it's only emerging, and, you know, we're not really seeing much of it. And clearly your examples show that, yes, it is already happening. Just in the interest of time, I am going to move now to Dr. Carol Manassa, who is Associate Professor of Civil and Environmental Engineering at the University of Michigan. And actually, as a bit of introduction, because I think that very often one of the arguments raised is that, oh, are robots going to replace humans in the construction? And I think that this is one of the issues that Carol is going to talk about in her presentation. So welcome, Carol, the floor is yours.
Yeah. I'm going to stop Thomas's Okay, good afternoon, everyone. Thank you for having me for this presentation. What I'm going to be talking about is talking about how robotics can assist in transforming construction work, with particular focus on how it can assist in transforming the construction worker of the future. So this is the brief outline of my presentation today. I'm going to go through a quick historical perspective of on-site construction work, go over some of the work we have been doing and looking at levels of human-robot collaboration in construction work, talk a little bit briefly about the two projects that we have from the United States National Science Foundation, and conclude with some remarks. So even though we're saying that there are a lot of robots and advancement in robotics in construction, what I want to show you is that there are still a lot of construction sites around the world that look very similar to what they looked almost 100 years ago. So this is a very old, very famous picture from the Empire State Building in New York. And we see similar situation right now on construction jobs. Similarly, here you see guidance, like a green guidance, early from the 1930s. Similarly, we still see similar situations at this point. And here we are pouring concrete, and we still see similar situations. So the main reason why I wanted to show these pictures is to highlight that construction still. Productivity in construction, even though there have been advancements and a lot of research and work done in construction robotics, productivity in construction globally still is very low compared to the economy. So it ranks at 1% per year compared to almost 3% for the total economy. And when we talk about manufacturing in other sectors, that's even higher. In terms of safety, it's the #1 in terms of fatalities. So there are a lot of accidents that happen on construction site leading to fatalities and also injuries. More importantly, I think construction because of how physically demanding it is, it doesn't allow for people of different abilities, women and other members of our community to be part of construction. So here in the US, only 4.5% of women contribute to the or are part of the construction workforce. And last, I think currently we are facing a huge labor shortage in construction sites, whether in the US and across the world. In 2020, around 81% of the general contractors reported shortage in skilled labor or finding skilled labor to work on their construction jobs. So there has been a slow adoption of construction robotics by the construction industry. And here, what I want to try to show is some of the compare why manufacturing has been faster to adopt robotics compared to construction. So in manufacturing, we have a controlled environment. In construction, it's usually unstructured environment. We have in manufacturing, we're producing identical products. Construction projects typically are mini projects, so you don't produce the same building over and over again. The work pieces move to the robots. In the case of construction sites, the robot has to localize itself and move to the work piece to be able to complete the job. And in manufacturing, we have tight tolerances. In construction, we have loose tolerances. So we often see a lot of discrepancies between as designed and as built in construction projects. So moving on, typically to complete a construction task, a human would need cognitive skills, planning skills, as well as physical skills to complete such a task. So when we think about robots, we think that the robots can eliminate the physical burden and take over all the physical work that creates back pain, neck pain, etc. for construction workers. And we think that we can leave the cognitive and planning part of the task to the human worker. However, our research team also thinks that with the advancements in artificial intelligence, we can have the robot not only do the physical work, but assist the human in terms of cognitive and planning. And I'll show some examples in the next slides. So with that, we can say that we can create very efficient human-robot teams by capitalizing on humans being creative in the design. They're adaptable, they have perceptual understanding, and they learn from experience. Whereas the robots have high physical capability, they have minor deviations detection, so they can detect any deviations from as designed. They have fast numerical computation and high speed connectivity. So combining the skills, or if you want the experiences of both the human and the robot, we can ensure have safer, more productive, less demanding, less physically demanding jobs, and more inclusive, especially in terms of attracting, like I mentioned earlier, people with different abilities as well as the younger generation to the construction. So keeping that in mind, what our team has looked at is like what are the different levels of human-robot collaboration that could be incorporated in construction. And you can see here on the spectrum, we have from pre-programming and completely pre-programming the robot all the way to giving the robot full cognitive and planning abilities and it becoming fully autonomous. So what I'm going to do in the next slide is just talk about each one of these levels and show some examples of what they mean and how they can be incorporated on construction. So for the first one, the pre-programming, obviously the human still has all the planning work and the robot would execute the construction. So in pre-programming, the robot executes a pre-programmed work plan. So you give it a plan and it just goes and builds it. It's very similar to what you see in manufacturing. The robot has to be transferred, assembled, and localized on the work location. And like I mentioned, it's very similar to a manufacturing environment. So what you see here on the right-hand side is the SAM robot, which is very popular in the US for brake laying. If we go to the next slide, okay. The main problem with pre-programming robots for construction work is that construction sites are cluttered and unstructured environments. So this leads to, there is also, like we mentioned earlier, low tolerances and lack of quality control. So this might create a significant amount of rework, or the human has to be heavily involved in every step of the construction process. So moving on, thinking about how this can be, or what are some of the advancements that have taken away some of these, if you want, disadvantages of pre-programming robots for construction work. And the next level would be adaptive manipulation. So let me explain what we mean by that. So in this level of human-robot collaboration construction, should program and control the robots. However, the robots use building information modeling or any 3D modeling combined with sensors to adapt to the work plan. And so what I mean by this, so typically on the construction site, we have where you want to incorporate robots, you have sources of spatial uncertainty. So that means we have error in estimating correctly estimating the pose or the location of the robot. And also we have the construction tolerances that I keep referring to. So typically what you see here, for example, the location of the window or the actual location of the window deviates from what it has been designed or what the BIM model has been designed for. So the main challenge is how to determine the actual pose and geometry of the workpieces. So what our team has done is we have created a method where that allows the robot to sense the construction workpieces, and I'll show you that in a video in a moment. It registers the BIM model to the sensor data, and then it adapts the work plan to the registered BIM model, and then it executes the adapted plan. So here you can see this is in our lab at University of Michigan. The robot has used the camera to sense the joint, and then it adapted the work, so it found that the joint is not straight as it was in the BIM model. It adapted its work plan for that. So here, the human is still controlling, still helping the robot realize what it needs to do, but the robot is able to adapt to the work. So we're giving it a little bit of intelligence for it to be able to complete the work on time. The next level that I want to talk to is imitation learning. In this level of human-robot collaboration in construction, we are inspired by the master apprenticeship model. So typically, how a construction worker is trained by attending a technical school, but then they get assigned to a lesson on the construction job that helps them understand or helps them learn that craft, if you want. So what we are doing is we are using advances in AI, particularly learning from demonstration, to have the human be the master that teaches the robot to do, in this particular example, quasi-repetitive construction tasks. So again, this is an example from our lab. We have a ceiling tile installation where we demonstrated this through and collected videos, so we're using computer vision as part of this. And then we trained the model and evaluated it in virtual reality for the robot to determine if the robot is able to learn from the demonstration that the humans have provided. So let me try to play this. Okay. So basically, we had a success rate of 80% in terms of the robot learning from the demonstration that we provided to install the ceiling tiles. But here we are maintaining that the grids are very similar to the grid that we used when we demonstrated, and there are no changes in terms of the size of the ceiling tile, etc. But we all know that on a construction job, you will encounter HVAC pipes, there'll be ducts, there'll be other issues that the robot will encounter. So not every tile it's going to install is going to be similar. So what we need to do is we need to provide the robot with a way to, if it is not able to learn all these special cases, how we can provide it a way to communicate with the human so that the human can help it adapt and then install the remaining special case tiles that we're talking about. So this brings us to this level, which is supervision and improvisation, which is the main, if you want, underlying foundation of the project that I mentioned earlier that we have funded from the U.S. National Science Foundation. So, like I said, our team is interested.
Sorry, Carol. Hi, sorry to interrupt. There just seems to be a bit of an issue with the audio. When you're speaking, there's some crackling going on. I'm not sure whether you can just correct that quickly, or perhaps come closer to the microphone on your laptop.
Okay, I'll try. Is this better?
Yeah, I think that's better, actually. Thank you.
Okay, thanks. So 1 second. So for this project, like I mentioned earlier, we are interested in advancing the construction worker and thinking about how, with the introduction of robots on construction sites, what role can the construction workers themselves play in this? So for this project, what we are doing is we are using learning from demonstration as the basis, where we can use virtual reality, augmented reality, and other methods where a human can train robot to do the quasi-repetitive task on construction jobs. And then on the actual construction side, the human would be to monitor the work that's being executed by the robot, but also to assist the robot in case it needs to improvise for the special cases. So I can think, for example, in ceiling tiles, we mentioned availability of an HVAC system that needs a different manipulation to place the ceiling tile, that can be a corner, smaller size tile as well. So in doing this, we are focusing on 3 main research areas, which is the construction workers themselves, obviously the digital and robotic technology and how we can advance that so it can assist construction workers in completing the work, and also thinking about how construction itself, how we design a building, how we manage a building, how we construct a building might be affected by the introduction of these robot assistants or human robot teams on construction jobs. I'm going to go through this very quickly, but these are some of the questions that our team is tackling in terms of this approach. And particularly, I want to focus on the worker side. For our project, we are involving workers in the development of the technologies. Some of the technologies that I showed earlier, we have tested them with construction workers, but of course, it's important to get feedback from them, because what we learned is that construction workers are interested in robotics, are interested in adopting or using robots on construction jobs if they feel that they are useful and they can use them in here. It's important to also focus on improving trust between humans and robots. So humans need to trust that the robot can do the work and can do it as expected. A large part of introducing robotics to construction sites is going to be education and training of the next construction workers, and then also thinking about advancement and upskilling. We are also interested in testing how some of these technologies can also result in younger generation pursuing careers in construction as well. For the technology, I think talked a lot about the technology, but assistive robots, we are interested in designing assistive robots that readily learn construction work tasks, that can adapt to the work plan and follow worker instructions, and can communicate and common situations with human workers. So we are using a lot of natural interaction methods, for example, natural language processing, etc., to achieve this for the technology part. And last but not least, thinking about the work or the construction process itself, thinking about how the advancement of human-robot assisted collaborative work can facilitate work, but how we can use digital technologies, for example, to facilitate collaborative human-robot teams, and also be able to measure the barriers, what is the expected productivity and quality improvements from introducing such teams to construction jobs. So with that, I'm going to offer a few concluding remarks. First, we work with the premise that robots will never be able to replace construction workers unless construction itself changes, unless we're building every building exactly the same, like we do with cars and computers, etc. Human workers are good at planning, sequencing, and improvisation, so we want to capitalize on that so that they can assist robots to complete the construction work. Previous research in construction robotics assigned physical aspects of work to the robots, but retained planning and cognitive components. However, now with the advances in computing, this will allow us to explore new ideas where robots can participate in cognitive and planning aspects of the work in addition to the physical work. With that, this is a video I think that I shared with ITU. So unless I'm not sure how much time I have left, but I'll probably refer you to the website. It is available on the website. Then with that, I would like to conclude my presentation, and I would be happy to answer any questions now or later in the networking session. Thank you.
Thank you very much, Carol. Again, very interesting presentation. I must say that I was really happy to see on your graph that the humans are going to be still involved in many stages as we progressively move towards more and more robotics. We may not be changing the way we're doing things entirely, and it's good to know that there's going to be still place for humans, and also that possibly construction has an opportunity to become more exciting field, because there's going to be the whole set of new digital skills needed. I am going to skip my short questions in the meantime and just move it all to the panel at the end, because I don't want our other two guests to feel that they have not enough time to present their research, their projects, what they are doing. So let's move on now to Dr. Bharat Sankaran, who is CTO and co-founder at Scaled Robotics. And as far as I know, he is going to touch on one of the challenges in construction as well, which is the huge carbon footprint that we are producing. Bharat, over to you.
Hi, Mishka, an absolute pleasure to be here. Let me go ahead and share my screen, and hopefully you guys can see it. Awesome. So today I'll be talking about how do you reduce waste in construction using machine learning and artificial intelligence. Briefly, I'm going to touch on the problem, how you can formulate this problem, what are the opportunities that are there for AI and robotics, and then how this problem has been tackled currently, or it's been looked at by academia versus industry, and where the challenges lie. So it's probably well aware to a lot of people that construction is one of the world's largest industries, but it also happens to be one of the world's most inefficient, along with logistics, transport, and healthcare, I think. It is so inefficient that nearly $1 trillion a year gets wasted because you're not able to plan. You're not able to match what you're building to what you're planning. In fact, construction is such a wasteful field that close to 30% of every construction project ends up in a landfill. That has an incredible carbon footprint. Not only does construction have an incredible carbon footprint, it also has an incredible economic footprint. Construction operates as an industry on razor thin margins. They operate on between a 1% to 2% margin. But if you think about construction, construction is pretty much a form of manufacturing. Yet every other form of manufacturing that we are aware of have margins greater than 50%, but construction is still operating on the 1% to 2% margin. So what is the reason, and why does this happen? Obviously, there's one effect that construction is on site and traditional manufacturing is done in-house. But the insight that we have, or the thesis that we have developed within Scaled Robotics, is that traditional manufacturing, the reason they have become so efficient is because they have implemented very efficient process control. And construction basically lacks process control. What is process control? You have a design process or a design plan. You start executing it. You measure what is going on in the real world during your execution, compare it to your design, and then see how the two things have diverged. So this is the basic idea of process control. If you're a math savvy or a control theorist, this would look something like that. but I've kind of broken it down into components to kind of understand what exactly is happening or how you can think of this problem with regards to construction. In construction, your plan can be represented with a BIM. A BIM is a building information model, and this is a 4D representation of the construction process. Basically, it's 3 dimensions over time. How does the project evolve over time, and how does the 3D structure evolve over time? Obviously, for a control theorist, the physical controller on a construction site are the people working on it, and the system that is in progress is the physical construction site. And the 2 end products that basically come out of any construction project is the physical building that you're actually trying to construct and the cost associated with it. So to do process control in this, you need some way to measure the state of what is going on and compare it to what you've designed, which is the way we think about this problem at Scale Robotics. How do we do process control? There's a lot of things happening on a construction site. There are people, there's logistics, there is material, there's a budget. But measuring the geometry of the construction site is a very representative signal of what is going on a construction site. If the geometry is wrong, it is fairly safe to assume that the process is not going well. And that is essentially what our thesis and the way we look at this problem is. We measure the physical geometry on the building and compare it to the design geometry and try to assess how these 2 things are diverged. Obviously, it's not as straightforward as this little diagram I put over here. There is one unique problem in construction is a construction site is an open system. An open system in the sense it's not a manufacturing plant. You're not inside a manufacturing unit where the environment can be controlled. So you have a lot of unmodeled noise that enters this system. How does that affect the problem of process control? And then I'll talk a little bit about what kinds of solutions you can think about to go about this problem. So how does that affect it? Well, the first problem in construction with regards to just the core problem without having an open system is a BIM model is a living document on any practical construction site. It's not designed once and then people sit on it. It keeps evolving over time. So this basically means that whatever you're trying to compare against is also evolving over time and it's not fixed in time. So this makes the problem fairly complicated. The second problem is the construction process is a highly nonlinear process. There is no relationship to what's happening on one floor to what is happening on some other floor. In fact, we have an internal joke at Scale Robotics, which is that the only thing linear about construction is gravitational causality. You can't build floor 3 before floor 2, everything else flies. Then the environment is fairly dynamic. Since it's an open environment, you have objects, material, people moving through the construction site, machines, all of these things. And all of this limits your ability to actually measure what is going on at the construction site in a significant manner. And the final nail in the coffin when you're trying to apply process control from a traditional manufacturing point of view into construction is heavily decentralized. On a typical construction project, you have a general contractor that hires subcontractor that hires more subcontractors. So everybody has their own reference plans of how the project is evolving. So it is very, very hard to have a strong reference signal that you can compare against to be able to do efficient process control. Now that I've kind of painted the very dark scenario of why this is very hard, this is where I'd like to talk about the opportunities. Given the nature of the problem, there are opportunities to apply AI and robotics within construction. And for particularly the problem of process control, which is trying to reduce waste and trying to keep the construction project aligned with the design so that it doesn't generate waste, is 2 locations where you can introduce artificial intelligence, machine learning, and robotics. So one is in the processing of the data. As I mentioned, there is, once you measure the construction site, you can use techniques in 3D vision, 3D machine learning, where you have incredibly complex noisy data that needs to be analyzed to figure out how this is diverged from the BIM. And the second aspect is how do you capture this data? Here you can use deployment of robotic technologies, SLAM, autonomous navigation, and all sorts of latest and greatest available innovations to be able to facilitate this measurement of the state on the construction site. And this is pretty much how you can think on a high level on how these problems are being tackled within academia and industry for the process control problem. Academia looks a fair bit at future-focused solutions on how do you go about capturing data? Can we rethink entire surveying workflows with robotic components? And are there new value propositions you can explore? And industry at this point, which is where I'm sitting, we are more curious about how do you integrate with existing workflows and come up with solutions that are better and cheaper than existing solutions, also trying to address the labor shortage. And this realizes opportunities. If you've seen most of you have come across some form of these robots, one of ours is also there in that picture. These are different forms of reality capture platforms where various levels of autonomy has been implemented to change the entire surveying infrastructure. How do you go about capturing data than traditional surveying? Can you do something more intelligent? Can you enable autonomy? Are you limited by the working hours of a construction site? And there's a huge discussion to be had there. And this is one of the areas where using automation can help. Industry is basically, all right, assuming you capture data in a traditional way, can you do something that humans cannot do or is a better solution than humans? And on my penultimate slide, I'm trying to show you a little video of what we actually are capable of at Scale Robotics in terms of process control. This is a complex construction site. As you can see, it's very hard to distinguish between what is the site and what is the stuff that does not belong to the building. Our algorithms, we use complex machine learning, computer vision techniques and optimization techniques to be able to automatically filter out the interesting signal from this complex site, and then do very efficient process control for our clients, where we can tell them what exactly is going on their construction site, what has been built accurately, what has been built inaccurately, and what is missing and behind schedule. So green means you've done a good job, yellow, you've done a horrible job, and red, it's missing. With that, I'd like to wrap up and thank my team, who are basically the brains behind all of these things. And one of the big things we keep talking about is how construction has a very bad representation of women. And they always say, you know, a charity begins at home, so why don't you be the proof for what you're doing? We are actively pushing towards having 50% female representation within our company. And in a small company of 35 people, we are close to achieving that. So you start there, you push the innovation, you bring in young talent, and everything else will follow. With that, I'd like to stop my presentation and take any questions anyone might have.
Thank you very much. That was, again, fascinating. And I really, of course, like the remark about women in construction. I'm hoping that, you know, we are going to finally reach the stage where women are going to be as well, not necessarily on construction side, because there are so many things that are happening around the construction. I am going to move actually to Errol, our last speaker, and actually, funnily enough, talking about women, I could possibly introduce him by asking a question: are we going to see women operating as well, these big excavators and diggers? Because this is one of the things that Errol is going to be talking about. So please welcome Mr. Earl Ahmed, Director of Communications at Build Robotics. The floor is yours.
Hello, and thank you for inviting us on this great panel. And that's a great question, and I'll get into it during the presentation because it is part of the future of construction. Well, we're Built Robotics, and we build the robots that build the world. And what that means is we build technology that helps construction sites become fully autonomous. And before I dive too much into my presentation, I thought I'd start off with a video that we made that sort of explains everything you need to know about the company in a short little clip. And let me just make sure I am sharing my audio. There we go.
We build the same way our grandparents did, with our own two hands. But the tools in our hands change. Built Robotics has developed the most advanced tool available on any job site today, the exosystem. It transforms any excavator into a fully autonomous robot made to dig the earth. It's powered by a liquid-cooled computer with sub-centimeter RTK GPS, high-efficiency solar panels, an all-weather, all-terrain design. And you can easily switch from manual to AI mode with a flick of a switch. But most importantly, it can dig. Does the idea of an 80,000-pound robot scare you a little? You'd be crazy if it didn't. That's why we've developed an 8-layer safety system with 360-degree camera coverage, proximity radar, 110 decibel safety alarms, ultra-bright LEDs, high-vis barriers, a digital geofence, and hardwired and wireless emergency stops. Because when it comes to safety, more is more. We're here because of the builders who came before us. They created the world we live in, our roads, our cities, our homes. And when they needed a tool to overcome a new challenge, they invented it. Now, it's our turn. We build the same way.
So as that video mentioned, we build the world's first autonomous upgrade for heavy equipment, and it's called the exosystem. And what it achieves is full autonomy on heavy equipment like excavators, where our primary focus is today. And it's an upgrade kit. So actually it is OEM and model agnostic. So you could kind of put it on any machine you have. And that's sort of a big part of our business strategy, and what customers really like is that you can add autonomy to what you already own, which reduces the need to produce more kind of specialized equipment. It is rugged and weatherproof, working in dust, dirt, rain, cold and hot weather, and any kind of condition that job sites have, which has been a long journey for us with testing and trying to figure out what makes robotics practical on job sites. I mean, there's always the disconnect between building things in a closed system, interior, indoors, and then getting it out in the field and seeing how people use it. And the robots today are focused on massive earth-moving projects, and I think that's the biggest benefit of robotics in construction, as we see it. You know, earth moving is sort of at the heart of every outdoor building project, and if you could try and automate that one piece today, you're going to unlock a lot of potential for savings and productivity gains and changing how we build the world. Energy, utilities, water, telecom, data centers, you know, anything that requires buried infrastructure is sort of what our robots focus on. And trenching is at the heart of that automated task. And when we look at robotics in job sites, especially with build, you know, how do we look at it? And the way our focus is aligned is to talk to our customers and see what do contractors and the construction industry care about. You know, they care about consistent production and utilization. You know, utilization is huge because in traditional utilization with a human operator, you're looking at anywhere from 30 to 50% utilization. But with robotics, that same piece of equipment can go from 50 to 80% utilization. And you get very consistent production, often at speeds the same or faster than manual methods. And of course, there's a labor shortage. Labor shortage is both because of the construction industry not keeping up with changes that other industries have with technology, and also not addressing the need to bring more kinds of different workers, like mentioned before, women, but also other kinds of people that traditionally have not been involved in construction, have not found it attractive. And I think the heart of all of it, of course, is for a contractor, you want to be spending less and staying competitive. And robotics really lets you unlock another level of productivity and efficiency and avoid rework. And that's a big one too. When you can utilize your robot, get consistent production, and not have to redo work, You're lowering the cost. You're getting to that level of manufacturing efficiency in the last presentation, bringing those percentages higher and higher. And finally, there's the analytics piece. The robot gets a lot of data, and what we can do with that data is still an open question. I mean, there's a lot that can be done with it. And right now, with our robots, at least, we're in the collection phase and kind of understanding what we can do to unlock the most productivity with the data. Here you can see how the robot works. So the upgrade kit goes behind on the tail of the excavator, and it's deployed in sort of a safe working environment with a fence around it and a deployment vehicle. And then it does trenching work at the push of a button. There are different kinds of configurations for the back and flexible mounting solutions, so that, you know, if you have a mid-size, large, or mini excavator, you can achieve proper installation. So the first part of robotics at Built is how does it improve the customer experience and make a better job site? The second part, of course, is safety and preventing injuries. Because as you know, job sites are incredibly dangerous areas, and we talk to construction workers who love their work, and often their own children want to get into it, and they tell us time and time again that they're worried because it's a dangerous job, and they don't want people to get hurt. So we take safety very seriously, and I think that's one of the benefits of robotics, not just productivity, but creating safer job sites. And we do this through an 8-layer safety system. This involves a number of physical barriers, fences, signage, warning signs, safety lights. These are for humans to let them know something unique is going on with this machine. And then we have virtual safety components for the robot, like geofences, IMU sensors, cameras, pedestrian detection. These are things the robot needs to know that it is working safely and correctly. And these come together to produce a safer job site, take the person out of the cab, and let them move on to other tasks. Here you can see what that looks like in deployment. There's the orange safety barrier. It's hard to see the sensors on the robot, but there are a number of cameras, IMU sensors, and things of that nature that keep the robot working safely. So that's how our robots work today in the job site. But how do robots tie in with sustainable development goals? And there are a lot of ways they can help, and what Built focuses on with earth moving is sort of at the very core level. You know, when you think about food systems, irrigation, when you think about sanitation and getting water to the right places, when you think about clean energy, solar farms, wind farms, when you think about climate action, building levees, building fire breaks for forest fires, you know, these are all things that require earth moving, that require infrastructure to be built and support cities and places where people live. And so trenching and that aspect of earth moving is actually at the heart of a lot of ways we think about sustainability and the goals we're trying to achieve on this planet. And finally, an interesting one is decent work, innovation, and growth. I mean, robotics, of course, we think of as innovative, but we also need to think about it in a growth mentality and creating decent work for people and equitable work for people. And a big part of Built Robotics' mission on that last point is the creation of new roles for skilled workers. So with the fact that you can't fill jobs in the United States, these are US statistics, by the way, contractors have a hard time filling jobs, but we have a huge backlog of work that needs to be done. How do we not only create robots, but actually get them used on job sites? And so the role of robotic equipment operator is a bridge that we think is an important part of that piece. You know, this is a new kind of career that we are helping to create and work with a number of educational partners. And a robotic equipment operator is the competent person on a job site who is trained to deploy and use our robots in a safe and productive manner, and tie into this whole idea that humans are good at planning, decision-making, creativity, and then robots can focus on those dull, dirty, and dangerous tasks and unlock a lot of productivity potential. You know, we built a software solution for the REOs, and they work on the technology to make sure the robot is running correctly and productively. And what that means is, to us, the future of autonomy is collaborative. You know, you can build a solution, it can work well. How do you get it into as many job sites as possible at a cost that makes sense for contractors? We're very practically oriented at Built Robotics. You know, we want construction to be a bigger industry, to have more people involved in it. We want to have technology be at the forefront. I think there's a stigma that construction is tech averse, but that's actually not true. They are always at the forefront of using new tools and technologies, but they have to be cautious because a lot rests on their shoulders. They have a lot of responsibility building our infrastructure, our homes, our energy. And then working with the right kinds of partners, standards bodies, educational trade organizations. Built, for example, has a contract with the International Union of Operating Engineers, the largest trade union for operators in the United States and Canada. And we have specialized training for their union members to get them up and trained on robotics so they can take that technology wherever they work on job sites. And so with collaboration and keeping the barrier of entry, the cost of deploying robots as low as possible, we think we can get more and more robots on job sites and unlock this potential and move beyond the horse and carriage era of cars and onto the future of automated web job sites. All right, thank you.
Okay, thank you very much, Earl. And with this, I am now going to open for the questions from the audience. There are a couple of questions, and I'll try to basically slightly rephrase them and ask them to our panel. Actually, the first question is to you, Thomas. So just checking, Thomas, are you still with us?
Hello.
Yes, you are. Yes, perfect. So we have a question. I think it's pretty interesting, seeing all the things that you showed us. Basically, one of the people in the audience is asking, when it comes to adoption of robotics, should we be focusing first on prefabrication and sort of, I would say more the assets that are maybe modular, and only then move towards, I guess I would say more putting robots into the wild, into the construction site? Should we sort of, first still go for the safety of this is industrial setting, prefabrication, and only then? What do you think? What are your thoughts on this? Or can this be done actually in parallel?
Well, it depends on the construction project. Therefore, I structured my talk also in this way, in prefabrication, on-site robotics, on-site automation, and deconstruction, and so on. So in prefabrication, it's easier, and we already have lots of experience because it's a little bit more like factory automation in the manufacturing sector. So you can use to some parts a little bit more what we know about automated machinery and industrial robots. But the real problem is on the construction side, and most things go wrong on the construction side. This is what also was my message I tried to tell when I gave my talk. So here, most things go wrong on the construction side, but on construction side, we can't use industrial robots. So construction machines are very special machines, just like agricultural machines. So here we have to develop new kinematics. And also, if the construction work itself doesn't change, because now it's made for human execution or human labor, and so we need a paradigm shift. So we have to change the environment, the ecosystem. This was when I mentioned the horse carriage without horses and stuff like this. So the first cars looked more like a horse carriage without horse. And then we got the whole car system with road networks, with fuel stations, and then the industry took off. And next we're going into hydrogen or electromobility and so on. So on the construction side, we have a different setting. We need different kinematics. We can't use industrial robots which had been developed for the welding of the car bodies. So we need a totally different approach, and then it can be successful. So So the big challenge is, of course, therefore I showed these robots had been developed in the last 40 years. They look different. I mean, the ones I showed, and you can check it, we listed about 300 robots in the Cambridge book. So I just showed you a couple of them, and it's really something new. It's maybe like we can compare it to the master builders of the medieval times when they built Brunelleschi, when he built the Santa Maria del Fiore in Firenze, or Villain d'Oncourt, the French master builder, when he did the French cathedrals. Those people, they not only designed the product, but they also were managers. They also designed, developed their own construction machines and built these gorgeous French cathedrals or the dome in Firenze. And they developed all the logistics, new machines. And even Brunelleschi, I think he was the first one who built the first horizontal tower crane in wood. So, you know, these people are very innovative and they make gorgeous buildings. And but not only they didn't think only about the building, but also about the machinery. And this kind of thing we need again. We need this kind of master builder type of person, but now using mechatronics, robotics, automation know-how, artificial intelligence in order to move forward, because the problem's getting worse and worse in the construction industry. It has been mentioned: labor shortage, quality problems, cost overrun, time overrun, and so on. So we need a paradigm shift. You know, we are wasting so much money. It also been mentioned. We're wasting money, we're wasting materials. So we really need this new type of approach, new kinematics, new processes. The process is more important actually than just the building information modeling, but you need the process control, and then, but it has to be in real time. You know, if you recognize something went wrong, it's too late. you need a real time process control. And then you can have successful construction projects without cost overrun, without time overrun, and at the right quality at the first time. Once you have to rework something, redo some construction work, it's already too late. You're wasting money and effort and so on. So it has to be right at the first time. And this, therefore, I think the construction side is very important. Let's call it like it's the final battle in the military sense. You know, if something goes wrong, you lost the war or the battle or whatsoever. So the construction side is very important, but of course it's prefabrication, it's offsite, it's on-site, it's both of it.
Exactly. Okay, thank you very much, Thomas. And actually, sticking a bit to that subject of paradigm shift, I would like to hear as well from the other members of the panel, without maybe pointing a finger. But the question is, if you could think of one change, one paradigm shift, one sort of modification to the way we construct things these days, what would it be that would actually enable maybe quicker and wider adaptation of robotics? I can see, Bharat, you're already unmuted, so I'm going to start with you. Would you like to share your thoughts on that?
I would say standardization across sites. So automation comes from predictability and repeatability, and that comes from standardization. The problem, at least the way we see it, and process control, all of these things, is ultimately, if you think about it, every construction site is bespoke. Knowledge transfer sits in the heads of few people. There's very little standardization. So this makes automation very, very hard. The reason manufacturing was able to accomplish that is because it was standardized as an industry. So standardization can have a humongous impact, whether that is, if you need to build a robot for every use case, you're never going to be able to have any impact. You need things that can actually generalize across various sites, as you say. So standardization would be one of the biggest things, standardization and repeatability, in terms of processes, in terms of materials used, that could have a humongous impact.
And maybe one thing to mention here, because I guess that people very often think like, oh, if we standardize, is everyone going to live in exactly the same house and all offices are going to look the same? But of course, we have as well the concept of platforms, and actually looking not necessarily at, you know, oh, we are going to now standardize the family homes, but rather the components that we can then use to build these assets as we go. Carol, would you like to share your thoughts? It's like, if we could change one thing to help robotics conquer the construction.
I think, can you hear me well?
Yes.
Because I know there was a problem before. Okay. So I'm thinking of two things, if you allow me. The first thing is probably we should stop thinking of construction as similar to manufacturing, because if we continue to think like that, I think we wouldn't have some of the greatest structures in the world that we all admire and enjoy visiting. That's one thing. The other thing, I think construction is a multi-industry cooperation, if you want. So material, there needs to be paradigm shifts in the type of material we use, how we construct, how we design buildings, how we construct them, maybe the methods, the tasks that construction workers will need to be changed so that we can facilitate the use of robots on construction jobs.
Thank you very much. And we're going to Errol. Errol, one thing, or maybe two, if it's short, that basically would help.
Yeah. I mean, I think de-risking robotics is probably the biggest barrier to getting them on job sites today. And de-risking is not just safety, that's a big part, but the perception of cost, the perception of deployment, the perception of will this disrupt my job site? Will I be able to meet my timelines? I think it's getting people comfortable on job sites using robotics and really viewing them as another tool. You know, if you went to the hardware store or you went to a supplier and got something to use, you think about robots in the same way. It's not this huge momentous thing. Maybe we like to talk about it in that way because it is exciting to us, but for the foreman on the job site, for the person operating these robots, you know, they want to just rent one, get on the job site, use it, have it finish the task, and then move on to other things. So I think de-risking, the mental and literal de-risking of robots is important.
Okay, thank you very much. So I'm just conscious of time, and there's one question that I would again like to get the thoughts of all of you on, and I think we are going to basically wrap up after this. But it seems that there is still a bit of nervousness and unrest regarding, okay, are actually robots going to replace humans? It's like, you know, how is this all going to evolve? And is it that, you know, maybe now we are going to be teaching them and then they are going to take our jobs? So basically, how do you see that future relationship between the robots and humans? Because I think that the very quick answer is that, well, you will always need an element of creativity. So, you know, even if we move away from construction, we will still have humans in design. But what are your personal thoughts? Where do you actually see at some point us having totally autonomous, human-free construction sites? And that's just maybe a cycle the other way around. So Errol, I'm going to start with you.
Well, this is one of the most exciting questions, and it's a common one, but geez, where do I begin? I think I'll try and keep it short too, but I think the short answer is no. I mean, there'll always be a place for humans, and if we look historically, I mean, we used to dig with shovels and horses in construction, and now we got hydraulics and excavators, and then now we have autonomy. And each moment, you actually end up growing an industry and making more room for more people. And you make room for more people who have different kinds of skills. You know, older forms of construction were all about manual effort, and a certain type of person could do that really well. And over time, you got more intellectual, more creative people. You got people with different skill sets. I think with autonomy, we're going to start attracting people who never thought they'd be part of construction, and we'll be growing the industry in that regard. And so, you know, the fully autonomous job site, I think it makes sense in very dangerous situations where autonomy would be preferred, but I think there'll always be a place for humans, and there should be, because robots will be building for us, and we need to be involved in that process.
Super, thank you very much. I could see Carol nodding her head when you were talking about skills, so Carol will go next to you.
I basically agree with what Errol said. I would like to add that first, construction laborers, they like to do their craft, so they are very good, very skilled at doing their craft, and they enjoy doing it. So if we can use robots for good, so based on our webinar today, and make sure that they can assist the workers in the physical, or take away the physical burden, so reduce the amount of injuries they sustain, back, neck, knee injuries, make sure that they don't have to retire early at ages of 45 or 50 because they cannot do the job anymore. I think that's the way we can impact in construction. So along those lines, what is important is really to think about the role of the construction worker evolving. So maybe maybe the training, the education we give them would evolve over time, and that a robot would fully take over their job, and we would see like just robots all over and no humans on construction site. I think that's where the benefit of AI and benefit of robotics would be, is to assist humans in doing the work while still allowing them to be creative in completing the different tasks that they need to do.
Okay, thank you very much. Bharat, your thoughts?
It's going to be pretty much a combination of what Earl and Carol mentioned. Is we should see technology as force multipliers, not as replacements. So if you go with the horse carriage analogy, we never got rid of the driver. What has happened is the driver's skill set has been enhanced. So you have upskilled whoever that person was, and you've given them the ability to do something that they could never imagine before. A horse carriage can take you 50, 100. Now a person can drive cross country with a car. So machines, automation, all of this should be viewed as force multipliers. And one of the reasons why they will always be force multipliers is the moment you give a tool that can do something that a human cannot accomplish by themselves physically, now they will try to push the limits of what they can accomplish. So with the car, migration increased even larger. So now with the robot, we will start building even more complex structures. With what we have been already be able to build, we will start building in more efficient, different ways. So I don't think robotics, automation, AI is going to replace. It will just allow us to replace traditional low-skill tasks with high-skill tasks so that we're able to do more. But I don't think it will go out and entirely replace labor market. So construction workers will start getting paid even more. You know, if you can, there's this great analogy of the Harvard computer used to be a bunch of people who were sitting in a room, women mathematicians who were actually doing math. Today, it's a machine, and there are still mathematicians there. They're just using the machine to do way more complex math that could not be done by hand anymore. So the machine will be a force multiplier, and people will get upskilled, they'll get paid more for it.
And also, actually, when you were at the moment, you mentioned we are going to be building even more. I thought like there was a bit of scare on my face. I was like, oh, we should not be building too much. But that actually could be a very nice introduction to another discussion about robots and refurbishment and actually, you know, upgrading the existing buildings. But I am going to now just cycle back to Thomas. Thomas, you have the final word on, do we think that there's going to be totally autonomous sites before I wrap up? Is he still there? Maybe maybe there is no final word.
I think his mic is muted.
Let's see.
Something is wrong here. Okay, now it works. The many sites I've seen in the last 40 years and where I also was involved in, it had a different degree of automation. Sometimes there were only 30% of the people less working on the construction site, and the most advanced construction site had 70% less people working. So it depends on the degree of automation, on the approach. Basically, I don't worry about replacing humans, because when we look at the past, at the history, the agricultural society, actually everybody of us was a farmer. And then the Industrial Revolution happened, and then it didn't lead to, of course, the farmers became unemployed, but they went into industrial jobs, and the new jobs had been created. And this happened very successfully in Britain and in the United States and so on. And this created our worlds where we live in now. So I think it's a win-win situation. So we will have new jobs, new opportunities, And so I don't worry so much about this. And what you mentioned about the refurbishment, actually the cable-driven parallel robot we developed, I showed you on just 2 years ago on the site in Spain. It was for refurbishment, it was for rebuilding and upgrading the old buildings from the 50s, 60s, 70s, make them more energy efficient in Europe, because 98% of the building stock is already there. Only 2% of the building stock is going to be built as a new construction. So we have to, as mentioned, we have to refurbish, renovate. And there we have an even higher degree of labor cost, much more labor cost. So it will be even more unaffordable than it's already now, the new construction. So it's going to be more difficult to implement all this sustainable construction in the future if we don't robotize and automate more and more. So we need this kind of devices I showed you in our cable-driven parallel robot and more, and also the deconstruction I showed you already existed since 15 years. All high-rise buildings had been disassembled, so only 7% waste. And normally everything is waste, and then 93% of the high-rise could be reused. And that's I mean, this only possible because of this technology. And if we don't use it, we will have more and more problems. So I think the only way is to apply it, and then we will create new job opportunities, new professions. At the universities, we need new education, we need maybe new kind of faculties and so on, and new departments, and then we have a big opportunity. Otherwise, I think if we don't do it, it will create more problems. As you can see in the past, the countries that didn't develop further, they had really some problems. But the countries that moved ahead, they created wealth for their society.
Okay, thank you very much. And we are going to conclude with it. So basically, we can conclude that there is still lots of challenges, but these challenges actually offer lots of opportunities. So I think that, the phrase AI for good also applies to robotics in construction. With this, I would like to thank all of you, our brilliant speakers. I would like to thank our audience as well for their question. And actually, side note as well, I would also like to thank you not only for your presentations, but also for the work you do every day driving this robotics revolution in construction. And with this, I am going to hand over to Guillaume.
So thank you very much, Agnieszka, and big thanks to our speakers today, Errol, Bharat, Thomas, and Carol, as well to all the participants for making it such an interesting discussion. We encourage now to check out the AI for Good program online to see more robotic sessions that may be of interest to you. For example, on Thursday, the 16th September, we'll have a session on robots for the SDGs, leveraging AI-powered robotics for good with Hani Admoni, LJ Rig, Anthony Jules, and Deb Sign. Or on the 29th September, we'll be exploring how intelligent robots are being applied for space science and planetary exploration with Alina Albu, Schaffer, Marco Pavoni, Bandi Berma, and Yang Hao. We are very much looking forward to engaging with you in our upcoming events. This is the end of this section and the start of the networking in the AI for Good neural network with the panelists and participants for the next 10 minutes. So see you all in a couple of minutes. And now I give the floor back to Anna for the closing information. Thank you a lot for joining us today.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the satisfaction survey, connect with interesting profiles, or speak one-on-one using the chat and video function. After the 30-minute networking session, we invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits and poster boards, and build your personalized AI for Good program. It was a pleasure learning with you today. See you at the next AI for Good.